2. So 2.
Okay,
It would be 3, comma 2.
Good.
That would be the vertex.
Does this open up or down?
Opens up.
And I need 2 other points.
How do we do it? Oh, it'd be plus 11, maybe?
Yeah, no, I see what you're doing. And that's fine, except what if that's off the curve?
Right.
Give me some points down around here.
Oh, you could do, let's see, you could do 3.
No, we've done 3.
2.
In other words,
You could do 2, 3.
there you go. Well, we don't know it's going to be 2, 3. It is all we need is this point here, and then we're going to know what this point here is.
Right.
Because it's symmetrical.
Right.
So let's do this point there. So that is where x is equal to 2. What is y when x equals 2?
That would be 2 squared is 4 minus 24.
No, minus 12.
Oh.
Let me tell you the best way you should do these. If you have a pencil and paper in front of you,
Yeah.
this is what you want to do. And then solve each one. You can't make a mistake that way. That's 4
Right.
minus 12 plus 11. Well,
Right.
so that's minus 8 plus 11 equals 3. So it did turn out to be 2 comma 3.
Right.
And what's this comparable point right there?
That would be 4, 3.
And below or above,
Below.
which is this whole area.
Mm-hmm.
And solid or dotted?
Solid.
All right. Yeah, I think the vertex method is the best way also, rather than completing the square.
Right.
Let's see, do we want to do all of these? The trick on all of these is going to be graphing them.
Yeah. I think I'm okay on the graphing now.
Let's reserve 9 through 12, and if we have time, we can come back to it.
Okay.
Make sure we hit some of these different kind of questions, like 13.
Okay.
How am I going to answer 13?
I don't know.
Well, first of all, let's graph them.
Okay.
Now this one I can factor into x plus 5 times x plus 1,
Mm-hmm.
and that gives me my x-intercepts. In other words,
Right.
that means my intercepts are right there, and now I know it opens up, so my curve has to go through that, like that. But I never figured out the vertex, but where is the line of symmetry?
Right in the middle.
At minus 3. So I don't need to use the vertex. I don't need to go through the whole minus b over 2a. I know that at minus 3 is the x-coordinate of the vertex. What's the y value?
That would be 9 plus 18 plus 5.
Okay, do it like I suggested doing it.
So 9.
Then is it plus 18 or minus 18?
Minus 18,
Okay.
which is negative 9 plus 5 is negative 4.
Okay, so the coordinates on that thing are minus 3, minus 4. And that's 3, and that's 3 points. In other words, this one is minus 1, 0, and this one is minus 5, 0. So there's our graph, and this thing says y is bigger. So when they say give them one solution, what would it be? What would x be and what would y be?
X would be negative 3 and y would be negative 4.
Well, x is negative 3 is fine, but in order for y to be greater than that, I can't, that's not a solution. Y would then be equal to that. So a solution would have to have a y that's bigger than minus 4, right?
It would be 5 because you set x to 0.
Now hold on. Is all I need, when they say name one solution, I need a point that's in this area. And I need both coordinates on it. Okay? The point you gave me right there is on the line. It's not greater than the line. So how about we go up 1 to minus 3 instead of minus 4?
So
That's right there. That's in that area. That is a solution. Right. That is one solution. The vertex is not a solution. It would be if this said y is greater than or equal to. But since it says y is greater than, then the y value of our solution has to be greater than the line of the parabola.
So it would be negative 2.
Or negative 3. Negative 3 is greater than minus 4. Remember, at this point, the y value is minus 4.
Okay.
So anything higher than that qualifies.
Okay.
Also, I could pick a point over here, or I could pick a point way up here. How about minus 3 comma 10? That's a solution also.
Right.
Any point that's in my shaded area, any x, y coordinate.
Okay.
All right, this looks a little different. Let's graph it.
All right.
First of all, check to see if it graphs easily.
So wouldn't you just plug y in as x plus 1?
No. Well, hold on a second. Well, here's the line. The second line is this. Has a slope of 1, goes through y equal 1.
Oh.
And this, let's see, where is the vertex on that? It's 2 over 2, so it's at 1. So the line of symmetry on that parabola goes through that. And when I plug in 1, I get 1 minus 2 plus 2. So 1 comma 1, right there is my line of symmetry. And my y-intercept is there. So there's 3 points for the parabola. Solid line. Give me a point that is in that area. In other words, y has to merely be greater than that, but y has to be on that straight line also.
So y could be 2, comma, or...
How about x equal 1, y equal 2?
Yeah, that's what I was trying to get at.
In other words, there's 1, there's 2, so we're talking about a point. Let me get rid of my shading so I can see. We're talking about a point that is right there.
Right.
It's on the line. Has to be on the line because y has to be equal to, it's got to be on that line there. And it's got to be above the parabola. So it can't be down here, it can't be up there. Got to be between there and there. And we need an x and y coordinate. So x equal 1, y equal 2. Perfect, right there.
Okay.
That one was a little different. What in the heck happened to my page? Hold on.
No worries.
Yeah, I'll have to open it up again. Which one were we? Okay, we just did 14, right?
Yeah.
Oh, I see. These first two pages are the same, it looks like.
Yeah.
Okay. So we've done those two, and then this is different?
Yeah, it's just 11 through 16.
Okay.
Yeah.
First of all, let's talk about this problem. It's not really a division problem. It's not a factoring. It's not a factoring problem. How do I solve this? In other words, the problem with this is that I have an imaginary number in the denominator.
Right.
So that's what I have to fix. I don't have to divide. I have to just change that denominator to make sure that it ends up being a real number, not an imaginary number. What do I have to multiply it by to do that?
-1.
No, the conjugate of this.
Oh.
1 plus I. Well,
Okay.
I can't just arbitrarily multiply the denominator by that, but I can if I multiply the numerator also by that. Now all I'm doing is multiplying that whole thing by 1.
Okay.
All right, let's do the bottom first, just to show you that the bottom turns real. Let's
So
foil
I
that.
squared.
Yeah, it'd be what?
1 plus I squared.
Be 1 minus I squared.
Oh.
In other words, that's the difference of squares factored, which means that that must have started out like this. If I said 1 minus I squared, well, that would factor into 1 minus I times 1 plus I. So it's 1 minus I squared, which is equal to what number?
1.
What's I squared equal?
-1.
So what's that equal?
-1.
1 minus a minus 1 is the same as 1 plus 1, which is 2.
Okay, 2.
And now let's do the numerator. In other words, we've turned the denominator real because whenever you multiply by the conjugate, you eliminate those middle terms. So we're not going to have any I. However, we're going to have an I in the numerator, but that's okay. So let's do the numerator. Step by step.
That would be 4 plus I.
Hold on. 4 plus what?
I.
Okay, I'm going to multiply it, FOIL it. That times that, and then that times that. So it's 4 plus.
4 plus 4I.
Okay. And what?
Negative 6I. And then negative 6I squared.
Okay. Now let's simplify that.
That'd be 4 plus 4 minus 2I. Minus 6I squared.
Okay, what's I squared again?
That'd be negative 1.
So what's minus 6 times negative 1?
Positive 6.
Okay. All over 2. Let's simplify it further.
2. That'd be 2.
What's the real number on the numerator? In other words, don't do that yet. Let's add that to that.
So that would be 10.
And then finally, the final simplification.
2. So that'd be 5 minus 1I. Well, minus I.
Uh-huh. So that whole thing turned into that. 5 minus I, all in the numerator.
All right.
Okay, let's do another one of those. 12. You said 11 through 15? You have to do 12?
11 through 10. No. Sorry, what am I doing? 11 through 16.
Okay. So how am I going to do this?
So, you would do, let's see, hold on. 3 plus 4I over 2 minus I. You'd multiply the numerator and the denominator by 2 plus I.
Good. That's called the conjugate. It's the conjugate of 2 minus I.
And
What's that make in the denominator?
that would be 2 minus I plus I. That'd be, let's see, 4 plus 2I.
Okay, it'd be 4 minus I squared. Remember, the middle terms always go away.
Okay.
In other words, we would have had 4 plus 2I minus 2I minus I squared.
Right.
This always happens when you've multiplied by the conjugate. So you can kind of skip the middle two terms and just do the front and back terms. And when you do that, you get 4 minus I squared. What is 4 minus I squared equal to?
That'd be negative 4.
Okay, let's do it this way. I squared is negative 1.
So it'd be plus 4.
What's 4 plus 1?
5.
Okay, let's multiply the numerator. What do you
So
get?
that'd be 3 plus 4 I times 2 plus I. So that'd be 6 plus 3I plus 8i plus 4i squared.
Okay, simplify that.
Would be 6 plus, that'd be 11i plus 4i squared.
What's I squared equal to?
-1, so that'd be 5.
Okay, hold on. It seems to me you're getting your addition confused with your multiplication. This is multiplication.
So that'd be -4.
Uh-huh. When I was
Okay.
doing 4 minus I squared, that is subtraction. That's not multiplication. Right. So that becomes 4 minus a minus 1. That's 5. But this is 4.
Right.
Minus 4.
So then it'd be 2 plus 11i over 5.
And that might, yeah, that's the correct answer. I'm just not sure if she wants you to turn it into this form.
We haven't quite learned that yet.
Well,
so.
That's A plus BI. That's standard format for a complex number.
Okay.
So, yeah, I didn't know. In other words, if she accepts that, that's fine as an answer.
Okay.
If the question says put it into standard format, then you have to split it up into 2 fractions, that one and that one.
Okay. Okay.
What are we going to do here?
So you're going to multiply the bottom by 1 minus 3i and the top by the same.
Okay, what's the bottom turn into?
The bottom turns into, that'd be negative.
Do it piece by piece. Don't do the whole thing at once.
Okay.
It's 1.
Yeah.
And then what? What's the last part of it?
That would be 1. I'm sorry, my brain is not working right now.
What's those 2 numbers multiplied together?
9.
Minus
Negative
9i squared.
Okay.
Okay. What's that turn into?
That turns into 1 minus 9 minus -1.
Okay, it turns
So that
into
would be -8.
No, hold on. 1 minus 9 times -1, not plus -1.
Oh,
Okay, which is 1 minus a minus 9, which is 10.
oh, okay, I see.
Okay. What's the numerator?
That would be 3 minus -9i.
No, the minus already took care of the minus sign. In other words, when I multiply 3 times this, it's 3 minus 9i.
Oh,
I have to multiply the 3 times the 1, then I have to multiply the 3 times that, and I get minus 9i.
right.
Okay, and that's your answer.
Oh, that was easy.
Yeah, that was a little easier. That's because the top didn't have much going on. Ah, that's a little different. remember our only goal is to realify the bottom.
Right.
So how can I do that?
So you multiply it by negative I?
Yeah, or I can just multiply it by I over I. In other words, it's true that the conjugate is negative I. But in this case,
Okay.
I don't need to multiply by the conjugate. All I need to do is multiply by anything that'll turn that denominator real. When I multiply
Right.
by I, I'm going to end up with I squared, which is negative 1, which is real. And it's actually easier to do that than it is to multiply it by minus I over minus I.
Right.
Okay, so the denominator is minus 1.
Mm-hmm.
What's the numerator?
That'd be negative 3 times negative 1,
Hold on.
right? Or would it just be minus 3i?
There you go.
Okay.
No,
Minus 2y squared.
there you go. Simplify that.
That would be, that'd be negative 3i minus, let's see, negative 2 times negative 1. That would be positive 2.
Good. So that would be 2 minus 3i all over minus 1. It's another way to write that, a little prettier form.
I don't know.
It's the same as 3i minus 2.
Okay.
Now, and that brings us to a good point, which is, had I multiplied by the conjugate, I actually would have been a little better off. Notice why. It leaves the denominator as plus 1, and now I don't have to do anything as a final step.
Right.
And it would also leave me with 3i minus 2 in the numerator. So I take everything I said back. When you're dividing by I, it is best to multiply by the conjugate. It avoids starting with a negative 1 in the bottom.
Right.
Whereas I times minus I is minus I squared, which is positive 1.
Okay. So just multiply by 5 minus 3i on the top and the bottom. And you'd get 25 I. Plus I. No, minus I.
First of all, you're multiplying that by that, and then you're going to multiply that by that. I don't need to worry about the middle terms. They're going to disappear. But I need the first term and the last term. First term is 25. What's the last term? What's
15.
that times that?
Negative 9.
I squared. Okay. What's that all equal? In other words, after you do these over and over, you get to a point where you see that always turns into a plus. So what's that denominator become?
Minus 9. So that would be 25 plus 9.
34. Okay, what's the numerator become?
That would be 8 times 5 is 40. Minus 24i minus 60i plus 36i squared.
Simplify that.
That'd be 40 minus, let's see, 80 36.
Probably worth, yeah, it's probably worth doing those two terms first, because that's the real part.
Okay.
So what's 40 plus 36I squared?
Okay, so that'd be 4.
Okay. Now combine those two, which you did,
So,
minus 84I all over 34. Now there is something wrong with this answer. What is that? You would lose points of some amount if you gave that as a final answer.
Would you simplify it?
By doing what?
Dividing by 34.
Well, you got to divide by something that goes into that, and into that. What number divides evenly into all three of those?
2.
That's right. What does it leave me? So, in other words, I'm going to divide top and bottom by 2.
Okay, so that would be 2 minus a plus.
No.
Right?
Minus.
Oh, 2 minus.
In other words, there's no I squared anywhere. We lost the I squared when
42
Okay.
minus 42I over 12. No. Yeah. 17.
And there's your final answer.
Okay.
Okay. We got one more problem. We got 5 minutes. Perfect time.
Okay. Okay, so that'd be 5 plus 2I over 3 plus 6. Okay, so you'd multiply by 3 minus 6I. And let's see, that would be 9, well, geez.
Multiply that times that.
9 minus 18I squared. 36. Oops.
Okay.
That's what I did wrong.
What's that equal to? What's the new denominator going to be? 9 minus 36I squared.
That would be 9 plus 36.
Okay.
So 45.
Okay. Numerator?
That would be 15 plus that'd be minus 30I plus...
It's best not to jump around with your pattern. In other words, if you're always going to multiply that times that, the next step should be that times that. In other words, don't do that times that and then do that times that sometimes and not always. You know what I'm saying?
Yeah.
Okay. In other words, always do it first, outside, inside, last.
Right.
Even though I do prefer ET, but I think that a lot can be said of memorizing the same pattern always.
Right.
What's the next term?
That'd be plus 6I minus 12I squared.
Simplify it. What's the real part?
That'd be 15 plus 12. That'd be 27.
Okay. What's the rest of it?
27 minus, let's see, negative 30 plus 6, that'd be negative 14.
Or negative 20. Negative 24.
24.
Okay. Is that simplified?
Yes.
Think of 3,
No.
division by 3. In other words, 3 is a factor of 45, 3 is a factor of 27, and 3 is a factor of 24. So
So
divide
it'd be
everything by
9 minus 8i over 15.
Now we can't do much anymore. In other words, 3 still goes into this and this, but it doesn't go into 8.
Right.
And it doesn't matter when you simplify those that you go all the way down to the base. In other words, had I discovered, oh, well, I can divide it all by 3 again, then I would.
Okay.
All right. Ooh, man. Our sessions are long when you're used to half-hour sessions.
Yeah.
But you had a lot of problems to go over tonight, so.
Yeah, I did.
All right. Taryn, I will talk to you next week.
Before you go, can I grab your address so I can send you your check?
Sure.
Is that 180?
That's 80127.
Oh, okay.
And my name is spelled like that.
All right.
Okay. Do you know how much it is, or you want me to?
How much is it, just so I can make sure my dad knows?
Let's see. Let's see. I think this was only through. Hold on. Let's see. It was that through September 29th. So let's see. We've had 1.5 sessions sent in. Hold on. Let's see. So we had last week, we just had a session, and this week we had a session. I guess we had a full hour last week too. So we had 2 sessions since then. That's 64, so the total would be 170.
170. Okay, I'll let him know.
Okay.
All right, thank you so much.
Thank you. Bye-bye.
Bye.